Hi guys, it's Mrs. Glenn. Welcome to the 5.4 Factoring Trinomials video. Alright, so for 5.4 you need to understand how to factor a trinomial, and remember our standard form is ax squared plus bx plus c. So the coefficients that are in front of each of those terms, that's your a, b, and c. So for step 1 you need to multiply the first term by the last term. So if we know this is a, this is b, and this is c, you're going to multiply a times c. So a doesn't have a coefficient, so we know that's 1, and then c is 12, so that would be 1 times 12, which is 12. And then you're going to set up a t-chart that has your adding to 7, which is the middle term, and multiplying to 12. So remember am that I talked to you in class, so that you know the order it has to add to this middle term and multiply to the last term. And for coefficients, you always want to multiply to a times c. And if this coefficient is a 1, then it's just going to be multiplying to c. So just remember, it adds to the middle and multiplies to the last if there's no leading coefficient. If there's a leading coefficient, you have to multiply a times c. So now we're just going to list the factors that multiply to be 12. You want to start with the right-hand side first, and then see if they add to be 7. So immediately I think of 3 and 4, because I know 3 plus 4 equals 7. So now you're just going to take that 3 and 4 and substitute it back into the middle term. So step 2 is break apart the middle term, which is 7x, and we're going to change it into 3x and 4x. And then that 3 and 4 came from the two factors that we found over in the t-chart. So it's 3x and 4x that the 7x changes into. Then I just copy down the rest of the equation from the beginning problem. And now we're going to group and factor. So put parentheses around that, find the GCF of the left-hand side, GCF of the right-hand side, and then you combine the two GCFs, which is x and 4, and the common binomial, which is x plus 3. And you get your answer, x plus 4 in the first parentheses times x plus 3 in the second parentheses. All right, for number 1, remember we have to multiply a times c, so let's set up our chart. So remember, it has to add to be b and multiply to a times c. So let's do a times c first, which is 1 times 20, and that came from our original question. 1 is a and 20 is c, and so 20 is what we're multiplying to, and we're adding to b, and b is 9. So we're going to add to b. So we find the two numbers that multiply to 20 that also add to 9. So when I think of numbers that multiply to be 20, well, there's 1 and 20, 2 and 10, 4 and 5. And if I were to add any of those together, 4 and 5 would actually equal 9. So that's the one I'm going to use. So then we just take 4 and 5, and we're going to break apart that 9 in the middle of the original problem. So instead of 9x, now it's 4x and 5x, which adds to 9x. And then we copy down the rest of the problem from the original question. And now we're going to group and factor. So we're going to put parentheses around each side, find the GCF of the left-hand side, GCF of the right-hand side, combine the two GCFs, and factor our common binomial, which is x plus 4. And now here's the extra step, because it says write the solutions, roots, and zeros. So we have to set each of those parentheses equal to 0 and solve for x. So we're going to set x plus 5 equal to 0 and x plus 4 to equal 0, and solve for x on each one. So subtract 5 from both sides and you get x equals negative 5. Subtract 4 from each side and you get x equals negative 4. So you're going to write your solution like this: x equals negative 4 and negative 5. And that would be the answer to number 1. All right, so for number 2, we have y instead of x. So just be careful when you're writing down your factors after you break them apart that you're putting y instead of x. And so we're going to set up our t-chart. Remember, it adds to be the b and multiplies to be a times c. So a times c is 1 times 1, and b is 2. So what multiplies to be 1? Well, there's only one thing that multiplies to be 1, and that's 1 times 1, or negative 1 times negative 1. So I know that 1 times 1 also adds to be 2, so that's what I'm going to use. 1 plus 1 is 2, and 1 times 1 is 1. So then I'm going to break up the 2y in the middle into 1y plus 1y. And then I'm going to copy down the rest of the original problem, which was y squared plus, and then plus 1 at the end. So now we're going to group and factor. So put parentheses around each side, keeping the sign in the middle separate. find the GCF of the left-hand side. They both have a y in common, leaving y plus 1 inside. The right-hand side does not have a GCF, so we're going to just put 1 there as a placeholder, and then copy down the rest, which is just y plus 1. And then our two common binomials match, so we can keep going. So our two GCFs are y plus 1 in one parentheses, and the common binomial is also y plus 1. So a shortcut way of writing y plus 1 times y plus 1, because they're both the same, would just be y plus 1 squared. So that would actually be the answer, is y plus 1 squared. But we also have to find the solutions, or the roots, or the zeros. Solutions, roots, and zeros are the same thing when you're talking about a quadratic. And so it's just where the line, when you graph it, crosses the x-axis. That's why we call it zeros. So we're just going to set y plus 1 equal to 0. We only have to do one of them because they're the same equation. So we subtract 1 on both sides, and you get y equals -1, and that would be your answer. All right, so for number 3, I actually want you to pause the video and try to do this one on your own, and then hit play and check your work and see if you have the right answer. So go ahead and hit pause right now. I really mean it. Hit pause. All right, welcome back. So I'm glad you guys worked out the problem on your own. Let's see if you have it right or wrong. Okay, so first thing you're going to do is set up your t-chart. Remember, it has to add to b, which is 2, and multiply to a times c, which is 1 times -8, which is -8. So then you're going to list everything that multiplies to be -8. So that would be 2 and -4, or -2 and 4. You also have 1 and -8 and -1 and 8. However, 1 and 8 are 7 away from each other, and we have to add to be 2. So I'm not even going to include those because they don't even get close to 2, which is what we have to add to equal. So I'm going to pick the two that are only 2 away from each other so that we aren't wasting any time. So 2 plus -4 is -2. That's not what we're looking for. But -2 plus 4 does equal 2, and that's what we're looking for. So I'm going to use -2 and 4. So we break apart that 2x in the middle, and we put -2x plus 4x. Then we copy down the rest of the problem, and we're going to group and factor. So you're going to put parentheses around the left and the right-hand side, find the GCF of both sides. Both common binomials match, so we put the two GCFs together and the common binomial together in the other parentheses. And then you have to set each of them equal to 0 and solve for x. So we subtract 4 on the left-hand side and get x equals -4, and we add 2 on the right-hand side one, and we get x equals +2. So our two factors, our two roots, are x equals -4 and 2, and that's also known as the two solutions, or two zeros. So if you got this one right, good job. If you didn't get this one right, I would recommend going back and seeing how my work is the same or different as yours, and see where you made your mistake, so that you can not make that mistake next time, and make sure that you're careful next time when you get to that part that you might have messed up a little bit. All right, let's go on to number 4. All right, I'm going to try something different for this screen. I'm going to try to show you writing in live time, kind of, but I pre-wrote it, if that makes sense. All right, so number 4, set up your t-chart. So remember, it has to add to b, which is 1, and multiply to a times c, which is 1 times -6, so that's -6. And then we're going to find everything that multiplies to be -6, so we have 2 and -3, and also -2 and 3. The reason why I chose those two is because 2 and 3 is 1 away from each other, and we're trying to find what adds to be 1. So then on the left-hand side, if we add 2 plus -3, you get -1, so we know that one's not it. And if we add -2 plus 3, we get +1. So those are our two solutions, our two factors. So we're going to take g that's in the middle and break it apart into -2g and a +3g. And that came from the two solutions we found in the t-chart, -2 and 3. Then we copy down the rest of the equation, the rest of the problem, and we're going to group and factor. So we put parentheses around both sides, find the GCF of the left-hand side, then the GCF of the right-hand side, see if the two parentheses match was our common binomial, and they do. So combine the two GCFs together in one, and our common binomial in the other. Then we set each of them equal to 0, and solve for g. So we're going to subtract 3 on both sides, giving us g equals -3, and g minus 2 equals 0. So we add 2 to both sides, giving us g equals 2. So our two solutions are g equals -3 and +2. All right, so for number 5, you're going to set up your t-chart again. It has to add to be -2, which is b, and multiply to -3. And remember, -3 comes from a times c, which is 1 times -3. So we're going to list the two possible ways to multiply to be -3. So that's either 1 times -3 or -1 times 3. Then we add those two together to see which one adds to be -2. So if we add 1 and -3, you get -2. So there you go. Those are our two factors. But just to show you why the second one doesn't work, would be -1 plus 3 would equal +2. So that's not what we're looking for. All right, so we're going to take that 1 and -3 and split it apart from the -2a. So it's going to turn into 1a minus 3a, which does still equal -2a. And then we copy down the rest of the original question on the left and the right, and we're going to group and factor. So parentheses around, find the GCF of the left-hand side, and the GCF of the right-hand side is a little confusing because you got two negatives there. So -3 times what would get us back to our -3 from the original binomial up here? So that has to be a +1, because -3 times +1 gives us that -3. Then we're going to combine our two GCFs together and our common binomial, and then set each of them equal to 0. And you get a equals +3 for the first one, and a equals -1 for the other one, which means we have to list it from least to greatest. So a equals -1 and +3. All right, so for number 6, you're going to set up your t-chart. Remember, it has to add to be b and multiply to a times c. So we'll just put add to b so that you know it's adding to b. And so we're going to list all the possible solutions. So I'm thinking about ways to multiply to -30. So there's 6 and 5, 3 and 10, 1 and 30, 2 and 15. So the only ones that would also add to be 7 would be your 3 and 10 in some combination, because they're 7 away from each other. 3 is 7 away from 10, and 10 is 7 away from 3. So I'm going to list both combinations to multiply to -30 using 3 and 10. So that's 3 times -10, and also -3 times +10. And then add both of those together to see which one is the correct one. So if we add 3 plus -10, we get -7, and that's what we're looking for. So those are our two solutions. But just to show you why -3 and 10 doesn't work is because this ends up being a +7, and we're looking for -7. So now you take 3 and -10 and put the x next to each one and break apart your -7x into 3x minus 10x. Copy down the original problem and then group and factor. So for parentheses, find the GCF of the left. GCF of the right is a little tricky because we have a minus and a -30. So a -10x and a -30. So if you have -10 that you pulled out for the GCF, -10 times +3 will get you back to that -30 from up here. So we have to make that a +3 in order to give us back a -30 when we distribute. So our two common binomials match. So we combine the two x and -10 for our GCFs, and x plus 3 is a common binomial. Set each of them equal to 0. So x minus 10, we would add 10 on both sides, getting x equals 10. And then x plus 3, we would subtract 3 on both sides, giving us x equals -3. And then list the -3 first, because that's a lower number. So x equals -3 and 10. And I am going a little bit quicker because we've done 5 problems like this already, so you guys should be getting the hang of it. If you want to slow down, just go back and re-watch this number 6. All right, for number 7, same thing, set up your t-chart. So it has to add to be b, which is -11. That's a plus sign b, by the way. And multiply to a times c, which is 1 times 24, or just 24. Then you're going to list all the ways to multiply to be 24. Now I know it has to add to be -11, so we're going to use the 3 and 8 to multiply to be 24, but we're not going to use +3 and 8 because that would equal +11. So we need to have -3 and -8, because -3 plus -8 is -11. So we're going to use -3 and -8, so we put x's back on them. So -3x minus 8x is how we split up -11x. Then copy down the left and the right hand side of the original problem and group and factor. So parentheses, GCF, GCF, common binomial, put the two GCFs together. Common binomial is the other part of the answer. Set each one equal to 0. Add 8 for the first one, so you get x equals 8. Add 3 for the second one, so you get x equals 3. So your two roots are 3 and 8. All right, so for number 8, same thing, t-chart. So it has to add to be negative 14 and multiply to a times c, which is 1 times positive 49, so that's 49. And we have two different ways to get to 49, either 7 times 7 or negative 7 times negative 7. And remember, we're trying to get to negative 14 when we add them, so 7 plus 7 would be positive 14, so that doesn't work. But negative 7 plus negative 7 gives us that negative 14. So we're going to split apart the negative 14x into negative 7x and negative 7x. Copy down the original problem on the left and the right, and group and factor. So you get the left-hand side GCF, right-hand side GCF. The two binomials match, so you put the two GCFs together, x minus 7, and the binomial that matches is also x minus 7, which means we can write that as x minus 7 squared. And then you're going to set x minus 7 equal to 0 and solve for x. So you're going to add 7 to both sides, giving you x plus 7. All right, so for number 9, you're going to make the left-hand side as adding to negative 8, which is your b, and multiplying to a times c, so that's 2 times negative 24, which gives us negative 48. And you have several different ways to get to negative 48. You could either use 2 and 24, 3 and 16. Yep, 3 and 16. 4 and 12. 5 doesn't go in. 6 and 8 does. And then you have your 48 and 1, of course. So the ones that are 8 away from each other are going to be your 4 and 12. So if you have negative 4 times 12, that equals negative 48. And positive 4 times negative 12 would also equal negative 48. So if we add those together, negative 4 plus 12 is positive 8. That's not what we're looking for. But 4 plus negative 12 is negative 8, and that's what we're looking for. So we're going to take that 4 and negative 12 and put the x's back on, and copy down the original problem on the left and the right, and then group and factor. So the left-hand side has more than just an x in common. It also has a 2. So 2x is your GCF, leaving you with x plus 2 inside, because 2x times x gives you back to 2x squared, and 2x times 2 gives you back to 4x. Then on the right-hand side, you also have a negative 12 in common. So negative 12 times x gives you negative 12x, and negative 12 times 2 gives you back to negative 24. So the two binomials match, so we combine the two GCFs, 2x minus 12, and the common binomial, which is x plus 2. So you're going to set each of them equal to 0. So 2x minus 12 equals 0, so we have to add 12, then divide by 2, and you get x equals 6. Then the right-hand side, just subtract 2, and you get x equals negative 2. So our two roots are negative 2 and 6. All right, so for number 10, first thing you need to do is pull out the GCF between all three terms, which is y. And then you're going to set up your t-chart. So it has to add to be negative 15 and multiply to be a times c, which is 5 times negative 140. So that's negative 700. So for this one, because it's so large, negative 700 is a large number to try to find all of the factors that multiply to be that. So like I said in the other video, 70 is close to 700. So think of the number one thing that you think of when it equals 70. So that's either 7 times 10 or 35 times 2. So 35 and 2 go together because 35 and 20 are 15 away from each other. So we're going to do all the possible ways to multiply to equal negative 700. So that's negative 20 and 35, and then 20 and negative 35. If we add those two together, you get positive 15 for the first one. So that's not it. And if you add 20 and negative 35 together, you get negative 15, and that's our two factors we're looking for. So we're going to take negative 15xy and put back 20x and minus 35x, and then plug in the rest of the problem for the original question, and then group and factor. So find the GCF of the left, GCF of the right, combine the two GCFs, combine the common binomial, and then we have to set each one equal to 0, and solve for x. So you get x equals 7 on the left-hand side, and x equals negative 4 on the right-hand side. So our two roots are negative 4 and 7. Go Seahawks. Woo!